Okay, so what is my intention today? To give you an introduction about mycotoxins. I will talk about the three main groups of mycotoxins that you have to know. If somebody tells you, do you know what are mycotoxins? You have to say aflatoxins, ochratoxins, and fusarium toxins at least, okay? And then I want you to think, so I'm already asking you a small intellectual activity. While you're listening to me, I want you to think about emerging risk you think may arise due to mycotoxins, or that we are not covering with the current risk assessment in food toxicology, for example. I mean, you are from different backgrounds. You're here to learn, but I also learn from the different backgrounds you have, also on how to teach or how to explain the field of mycotoxins. So just tell me afterwards whatever you think, okay? I mean, I have some results, of course, but I want you to know, I want you to tell me what you're thinking about. So write down any emerging risk you think that I'm not covering while I'm speaking, okay? Because this is the new research area in mycotoxins that we are currently covering, okay? So first thing, what are mycotoxins? Does anyone know what mycotoxins are? They are toxins that are produced by fungi, so they are secondary metabolites. So fungi do not need them to live, but at some point they produce it, okay? But the key point is that some of these mycotoxins are able to produce acute and chronic toxic effects to human and farm animals as well, both. And the mycotoxicosis is the intoxication you get by the intake of food contaminated with mycotoxins. So basically it's that. And the key point is that they are food contaminants, okay? So just to give you a taste, one important thing is that we have different genera of fungi able to produce mycotoxins. But depending on what kind of fungi we have, we might have the contamination at a different step. For example, fungi from the genera Aspergillus and Penicillium tend to contaminate crops while they are stored, when they are in the silos, okay? When you store corn, maize, wheat, okay? But fusarium is an opportunistic fungi. So it prefers to contaminate cereals while the plant is growing, okay? So you can have contamination while you're storing the raw materials, or even when the plant is growing in the environment, okay? Depending on the fungi. So we know that there are more than 200 fungal species that can be toxigenic. But one thing is you might have the fungi, a toxigenic fungi, but you have to pay attention because they do not always produce the toxin. They need some environmental conditions to produce the toxin. So they will need a temperature, a humidity, a pH, also a substrate, or even the interaction with other compounds might help the fungal species to produce the toxin. So this is one key point when we are assessing the risk of mycotoxins, is that the presence, I don't know if it works, well, strange. The presence of the mold and the presence of the mycotoxins are not always correlated. I mean, you cannot say there's no mycotoxins because there's no mold. That's not true, because the mold can appear, then produce the toxin, disappear, and you're not detecting the fungi anymore, but the toxin is there. And the other way around, you can say, yeah, there is toxin because the mold is there. But that's not the key point, because if the environmental factors were not the correct one, the mold is there, but it's not producing the toxin. Okay, so that is an important thing to keep in mind when you are assessing the risk to human health related with mycotoxins. So around 200 fungal species, but we also know that there are more than 400 mycotoxins identified. The ones that you have in this slide are the most relevant ones, okay? So perhaps the ones that everybody knows is aflatoxin B1, which is hepatotoxic, and it's perhaps one of the most potent hepatocarcinogen for humans. Okay, we know that it causes liver cancer, and especially related in regions, for example, the southeast of Asia, because of combination with hepatitis, has a high increase in the hepatocarcinoma diseases and cancer. Ochratoxin A, for example, is mainly nephrotoxic, but fumonisin is neurotoxic for some species, but not for others. Okay, so the message here is that we have acute toxic effects, which are very diverse. We have chronic toxic effects, such as cancer, but you know, it's quite difficult to relate the exposure to a long toxic effect. They're basically difficult to detect. Here you have data from acute toxicity, from lethal dose 50, okay, from these, some of the mycotoxins that we know. So this is a really preliminary toxicological data. Do you know what is LD50? It's the lethal dose. So in your opinion, which is the most toxic mycotoxins in this slide from the acute point of view? Aflatoxin, because it needs a less amount of toxin to kill the 50%. And also you see that for the same mycotoxin, you might have a different sensitivity, okay, from animal species. So the key point is, which is the most relevant animal species to do the risk assessment for humans? I mean, we have to select also the gold standard studies to do the risk assessment. And I'm just doing some information for tomorrow. I have tomorrow another talks. IR classification that classifies the hazards based on its carcinogenicity capacity has studied some of the mycotoxins. Aflatoxin B1 is a clear human carcinogen, but we have ochratoxin A and fumonisin B1 that are also probable carcinogens. We don't know enough for others, so they have been classified as a group 3. Okay, so cancer as a long-term effect is also something that we always keep in mind when we assess mycotoxins. So human exposure, you talk about contamination of cereals, that's correct. Do you know any other raw material that can be contaminated by mycotoxins? Cereals is, I mean, FAO, which is the Food, Agriculture and Organization, Food and Agriculture Organization from the United Nations, you know, that works with WHO, considers that 25% of the crops worldwide are contaminated with mycotoxins, but above the limits that are regulated. If we don't take into account the limits, but only the detection limit of our analytical techniques, 60% of the crops are positive for mycotoxins, okay? So yes, cereals, but also nuts, spices, grapes, cocoa, coffee, okay? Just think about cereals and coffee all together from the economical point of view, what it means. I mean, there are raw materials that moves a lot of money as well. I mean, and the nutrition and the access of food worldwide is basically based on cereals, okay? So of course, mycotoxins can contaminate these raw materials, but they are really stable. So when you prepare bread or beer from these cereals, we can still detect mycotoxins there. So human exposure is basically due to the consumption of this raw material, but also from all the food commodities that come from these raw materials, okay? Do you see any other source of exposure? Feed, because we are going to feed our farm animals with cereal-based feeds. And if the quality of this feed is not good enough, we will have these mycotoxins in all our animals, and we are going to eat some of these mycotoxins or their metabolites. That's the case of aflatoxin B1 that is converted to aflatoxin M1 and can appear in milk, and we are going to have another source of exposure. Okay, so when we are thinking about the human exposure, we have to think like in all sources, okay? Okay, mycotoxins are not new. They are really old. This is the Middle Age. We have a lot of paints from Dutch painters, for example, from Bruegel. I don't know how you pronounce it correctly like that, Bruegel the Elder. This is a paint that is in Musée du Louvre in Paris. I mean, it's a renowned paint. They show the effects of ergotism. At that time, they didn't know that ergotism was related with mycotoxins. But indeed, they thought it was like St. Anthony fire, that a sacred disease, because they were eating rye in their places. And then when they were sending them to a church, and they were changing diet. So instead of eating rye, they were eating wheat or barley that was not contaminated with Claviceps purpurea, which is the fungi that produce ergotic alkaloids. Okay, so at that time, they didn't know that this vasoconstriction, that they were losing their legs and arms because of necrosis, okay, was caused by the contamination of food with rye ergot, okay? So now we know that these are alkaloids, such as lysergic acid and ergotamine, and these are regulated nowadays. I have a question for you. Do you know what is lysergic acid? You're too young. LSD. You know, the abuse drug, LSD, is basically lysergic acid. Does any of you have migraines? Do you know ergotamine? Do you know that you have some pharmaceutical drugs that are basically based on ergotamine? So here, a question for today or tomorrow. Why a mycotoxin can be sold as a pharmaceutical drug? Would you allow that? Just let me know. Who will allow that? Yes, you will allow that? Yeah. Who won't? I like your face because this is you're thinking about correctly. If the question doesn't make sense, is that you're in the correct way. Who will not allow? You will all allow. Okay. It depends on the dose and in the use, exactly. So that's the key point. Okay, so just because some people think about that is the hazard characterization that we'll talk tomorrow. Okay. So when we discover mycotoxins, we basically discover mycotoxins because in the 1960s, around 100,000 turkeys in farms appear dead. And they didn't know why. And they call it the X disease. So basically, a group in South Africa discovered that we were feeding the turkeys with a feed based on peanuts that were contaminated with aflatoxin B1. Okay, I have to say that if you want to earn money in the field of mycotoxins, you have to work with farm animals because the effect is immediate. With human health, we don't know how to quantify the economic burden of the disease. But in farm animals, they know very well that they lose the performance, the growth, the reproduction of the animals. So you have a lot of people working. Is any of you veterinarian? No, veterinarians know very well the effects of mycotoxins because they suffer the effect directly in the farm. Okay, so they are toxic and we are exposed to them. Aflatoxin B1 is regulated worldwide. But in Europe, we have 7 other mycotoxins that are regulated, and we have maximum levels that we have to comply in food. I mean, if your food is above these limits, they will block the food or retire from the market, okay, withdraw from the market. So now what I'm going to tell you is just a few tips, information about aflatoxins, ochratoxins, and fusarium toxins, okay? So I already told you, aflatoxin B1 is the most relevant one in terms of toxicity because it's a human carcinogen. It's produced by Aspergillus flavus and Aspergillus parasiticus. And we have to take into account both aflatoxin B1, but also its metabolite M1 that appears in milk, okay, that is also genotoxic. We have aflatoxin B2, G1, and G2, that they are classified because they have different fluorescence, but the regulation takes into account all the aflatoxins altogether, okay? So we do not always assess the risk of aflatoxin B1, we assess the risk of aflatoxins altogether. They are liposolubles, they are not destroyed while cooking, and they are really unstable under UV light. So that could be good because they are destroyed, but there are two problems. I mean, we cannot put the crops exposed to UV light because we need vertical storage. And if you work in the lab with aflatoxin B1 and you don't protect it from light, you will say, oh, there's no aflatoxin B1, or there's no effect, but you degraded it because you didn't protect it from light. Okay. So the mechanism of action is known as a genotoxic carcinogen. It's basically metabolized to an epoxide. In toxicology, when we see epoxides, we always think about a reaction with internal molecules such as proteins and DNA. And the carcinogenicity of aflatoxin depends on this ability to create adducts with guanine. Okay, so this epoxide is basically binding to DNA and is the main cause of its carcinogenic properties. Ochratoxin is another mycotoxin, which is toxic, which we know we are exposed to it. But here, climate makes a difference. Because if you are in the northern parts of Europe, it will be produced by Penicillium verrucosum. But if you are in the Mediterranean regions, it's Aspergillus ochratius or Niger or Carbonarius that produce the toxin. Okay, so we have different fungi that produce the same toxin depending on the environmental conditions. Okay, so ochratoxin A has another important thing when we think about risk assessment, is that it has a very long half-life. It takes 30 days to have half of the concentration of the mycotoxin in blood. So, I mean, it will be circulating in our body for many days, okay? Because it binds to plasma proteins, and it's transferred also to milk. So we can expose newborns via breastfeeding. It has a acute toxicity in many animal species, but the pig is known to be the most sensitive one, and sometimes it's considered the most relevant for human risk assessment. Okay, and we know that cause kidney damages in all mammalian species. So it's nephrotoxic also for humans, but the key question here is that we don't know yet too much about its carcinogenicity in humans. We know that it causes cancer in rodents. Some people consider it as a genotoxic. Some people do not consider it as a non-genotoxic. So the mechanism of action is unknown. So it difficults a lot the risk assessment, okay, because we don't know the mechanism of action. And then we have the last group, which is the fusarium toxins. And here we have a subgroup of toxins. When we talk about fusarium toxins, we think about fumonisins, trichoticins, and zearalenone, okay? Fumonisine is, if you have to think about one crop, it's corn. I mean, it's the main mycotoxin contaminating corn, okay? We can have many examples of that in the literature. It's not working now. But the toxicity is highly variable depending on the species. So how you do the extrapolation to human health. Is hepatotoxic and nephrotoxic in rats. We know that it's also carcinogenic in rodents, but we don't have enough information for humans. Okay, although it looks like it's not genotoxic. We have quite good human biomarkers. The same for aflatoxin B1, ochratoxin A, and fumonisine. We have biomarkers of exposure. Okay. Then we have deoxynivalenol, which is a kind of trichoticin, which together with zearalenone, which is the next one, are the most prevalent mycotoxins in cereals. Okay, we can find them worldwide. And it's called vomitoxin because in farm animals, it causes a lot of vomiting and anorexia in pigs, so they lose a lot of money in the pig farms because of these mycotoxins, so they really monitorize it because of the effect to pigs, okay? And contaminates a great amount of cereals. Just to give you an insight, also I told you to think about emerging risk. done in combination with aflatoxin B1 has demonstrated to diminish the genotoxic effect of aflatoxin B1. So there's a kind of interaction among mycotoxins as well. And then we have the T2 toxin, which is a toxin that is not very well known, but we know that it's immunotoxic, and we think it has been related with the toxic aleukia that took place after the Second World War in some regions of Russia. A lot of people were starving, and they were eating cereals that were wintered for many times, and they were, well, it was thought to be contaminated with mycotoxins, and a lot of people die because of this T2 toxin, okay? And the last one, I'm putting the structures because you see the effects are different, the structures are different. So, I mean, we have to assess really one by one. I mean, we talk about mycotoxins, but each mycotoxin is a role and is a risk assessment, okay? So this one is azearalenone and has a structure that allows it to bind to estradiol receptors. So it has estrogenic properties. So it might have also a relation with cancer, but endocrine disruption by endocrine disruption methods, okay, mechanisms. So this is what I wanted to do. And now what I want you to tell me if you can think about some emerging risk related with these mycotoxins that I haven't mentioned. You are thinking about environment. You are thinking about, yes.
One of the pressing risks are climate change and the geographic shift in this fungi that can be like expanded to Europe and other places. So the emerging risks for these toxins are big in the future.
So good, very good point. So as they depend on climate or environmental conditions to be produced, climate change might change the geographical, not only the geographical occurrence of these toxins, but also the appearance of new toxins produced by these fungi because things change. So that is a really important, yeah, congratulations for this. Some other emerging risk. Normally, when we do human health risk assessment, we have, if you go to EFSA, you know, which is the European Food Safety Authority, which takes the assessments for food contaminants, we have the assessment by compound one by one. Co-exposure mixtures. So we have here, one of the emerging risks is, yeah, food. One toxin can produce, one fungi can produce several toxins, but in any case, my plate is a variety of food. I have cereals, so I will be exposed to multiple mycotoxins. How do I assess this interaction from the exposure side and also from the toxicological characterization? Something else. Nowadays, we have higher analytical capacities, so we are able to detect more and more compounds. So we are able to identify more toxins, but we are calling them toxins, but we haven't characterized the hazard. We don't know if they're toxic. They could be some of the metabolites that are not toxic, okay? So a lot of compounds to test. Climate change, you already mentioned, mixtures, and also aggregated exposure. When we do risk assessment for food, we are just thinking about the intake via food. But in fact, we can have mycotoxins when people are working in, you know, in the waste company. When you do the recycling, they're separating the waste. There are a lot of molds, and they are exposed in occupational settings. The people that work in pig farms is plenty of mold. They are exposed to that. People that live in moldy houses because you have mold indoor, you are getting exposed to mycotoxins via inhalation. So the aggregated exposure is also a key point that we have to take into account. Just to give you a few slides to finish, this is the survey that is done in a yearly basis, okay, by the DSM, which is a company. It monitors more than 25,000 samples per year. You can see in this map the risk associated with mycotoxins, and you can see here, basically, in each region, we have the co-occurrence of more than 3, 4, or 5 mycotoxins. And if you see red, it's because it's a risk, because the raw materials are contaminated above the threshold that we have currently regulated. Okay, so this is the map of the world, where we monitor mycotoxins, and there is a high occurrence of many of them. And about climate change, this is a modeling that was performed by EFSA, by Battilani et al. They basically monitored the situation of Europe for mice in 3 different climate scenarios. The first one was the present. Here, assuming that we are increasing in 2 degrees our environmental temperature, and here will be the 5 degrees, extra degrees scenario. As you can see, this is for aflatoxin production in mice. Spain is a really hot spot, okay? But also Europe is becoming high. Normally we don't produce too much aflatoxin. But then if the 5 degrees, it decreases again the scenario. So this is the real situation that some models have raised for mycotoxins. And finally, if you are interested in that, there's a link to 2 videos from EFSA that they talk about the risk assessment of mycotoxins. Also, if you are not in mycotoxins because you don't like mycotoxins as much as I do, there are really nice videos for risk assessment, very short videos for risk communication, exposure assessment explained in the EFSA website, that you can, for pesticides, for many, many other compounds, so for the risk assessment process, but also compound per compound, you can go to YouTube channel of EFSA and you can have really nice short videos explaining things that you don't know, okay? And then I will also like to mention, Maya mentioned this morning, this is a partnership in Europe with 200 partners, more than 400,000 euros, where we are involved for non-genotoxic carcinogens and also for mycotoxins, which is called PARC. And I advise you to go to this website because it's a really huge European project, because it tries to cope with the paradox in toxicology, you know. We need to test more and more chemicals. We need to test for mycotoxins, for example. Only 8 are studied. We have data for 12. But we are talking about 400 substances that we cannot buy, that we have to produce, that they cost a lot of money, that we cannot even produce the amount sufficient to do a toxicological assessment, okay? That is the problems we have nowadays. We have to do it more quickly, and we also have to reduce animal experimentation because we don't want to use too much animals. So this is a paradox. More products to be analyzed, but less animals, but in a lower amount of time, okay? So this is what we have many publications related with that. I didn't want to go into detail. I just wanted to wake up after lunch. So if you have any question, comments, I'm open to it, or you just can email me if you want.